Okay, so some people have asked me to if I could make a video to show how to put together a hobby-grade quadcopter. This is going to be video one of a series of video which will run you through the different steps needed to put together like a decent hobby-grade quad, essentially. Now, in order to put together quadcopter, of course you're going to need a frame, and the options for frames are plentiful. There are many different frames you can buy on the internet and different vendors that will sell different frames of different sizes, and then of course you can also make a frame. So the first video is just going to run you through a few steps in order to make your own frame, if that's the route you wanted to go. And then of course the subsequent videos will be about how to attach all the required electronics to this frame in order to have a functioning quad. So the first video again is going to be just to talk about the frame, and then if you plan to buy a frame, then you're probably good to go right to video number 2 and start from there, where we're going to start talking about building a power harness, and hooking up ESCs and that sort of thing. So this is a frame that I've made. It's a custom frame. Basically uses polycarbonate center plates that are made of this stuff here, and then of course you don't need to use this. There are other materials you can use. Some people use wood, for example. You can make this out of wood, thin plywood. Same with the arms. These arms are made of aluminum, but some people will use wooden arms to make this. And of course for the center plate you can also use aluminum. There are other materials that can be used for the center plates as well. Aluminum is a little bit heavier, but it does have advantages, of course, where it will bend a bit, but it will not break as easily as, say, this or wood, for example. So this one, the one I'm showing you here now, is polycarbonate center plate and the aluminum dooms on it. And then I'm just going to run you through a few steps just to guide you a little bit through what you need to do in order to put a frame together. Now, of course, there are different kinds of frame you can make, different kinds of models. I'm just going to go with a basic sports frame, which is going to be laid out as an X-copter with an X-copter configuration, which means that this would be forward, backward, left, and right, for example, whereas a plus copter would be like this. This would go forward, backward, left, and right. Today we're going to build a configuration that's going to be an X-copter configuration again, where it will go forward like this, backward, left, and right. Now, when you build a frame, the most important thing is to build it around your flight controller. This is what your whole frame is going to be built around, because you need to fit this on there, and this is what's going to fly your frame. This is what's going to fly your model. So when you build your center plate with a very large frame, it's not as important, because essentially the arms will probably attach further away from the center of the board, where you're going to use different attachment to put the flight controller on there. Whereas with a smaller frame in a 300 or 400 millimeter size category, you are probably going to want to have some of the screws that are used to secure your arms onto the frame will also be used to secure your flight controller onto the frame. And so it's very, very important that they line up perfectly in order for your flight controller to fit on there, right? If you're unable to, if your holes are just off by a little bit, come time to go and put your flight controller on there, the holes are not going to line up with the holes on the flight controller, and then you got trouble from there. So now the question is, how do you go about doing that, making this line up perfectly? Well, in the best of in the best scenarios, to have the proper equipment to basically do this electronically, or cut it with laser cutters or whatnot. But I don't have this kind of equipment. I'm basically using a bench grinder, a press drill, and hand drill, Dremel. So very basic tools that anyone can, most people will have at home or be able to do this with. So then the first thing you want to do is make sure that your flight controller is going to be nice and centered on there. And we're going to do this with a KK2 board. So the first thing you want to do is draw X, go to each corner of your center plate. Pen here. And you're going to want to draw X with a fine pen, not nothing big, something quite fine. And you want to take your time to do this right. This is probably the most important part of the build process of your frame. Just to make a nice X like this, line like this, and then go to the other corner. I'm hurrying up now, so this is not perfect. I'm not going to use this plate today. And then you got a hex here now. And you're going to want to place your flight controller so that the lines go in the very, very center of each of the mounting holes on the flight controller. Each corner and each corner of the board is going to line perfectly with the lines you just drew on there. And then you take your pen and you mark each holes where it's going to mount. Right. After that, the other holes you're going to have to be concerned about, of course, are the holes on your arms, which are going to line up which part of these things, right? And then also you're going to have them right on the line. So, for example, this frame here has got this arm here has got these two holes here. One hole, for example, let's say this is my hole here for my my flight controller, right? Then you're going to want to have the other hole perfectly lined up, right? And drill that right there so that your arm is going to fit there perfectly centered and lining up with that line, so you don't have to end up having with crooked arms on the quad once you put that together. And then from there, the rest of the holes that you can put there are just basically pass holes. Holes like this you can see here. Those are pass holes. These ones are not as important, right? Having them lining up perfectly is more aesthetic than function, because they're not actually used to mount anything. They're just there to reduce weight and also to get wires going through there. And then basically, once you got that done, your center is put together. You're going to need some standoffs on there, right, where the flight controller is going to attach somewhere down here on this. Standoffs on top, and then something to cover the flight control board on top of that. And then from there, all you're going to have left to do is find a way to put some kind of landing skids on there. And of course, you need some kind of perforations on there so you can fit in a strap, a Velcro strap to attach your battery. Right? So if you forget to put some kind of perforation like this on there to fit a battery strap through there, then you're going to run into the problem of, how are you going to attach a battery on this? Again, there's a whole bunch of different options as to how you want to do that. Some people would like to run the battery on top. I prefer to run it on the bottom. And I'm running little landing skids on there on each corner screws. So you can see I got a total of 8 screws on there, 2 for each arms. One of each of these arms, screw on each of these arms, one of them screws is used as, it's a bit longer, and I put a little landing skid on there for this particular frame. And then the center screws on the inside is where the flight controller is going to mount to, right, somewhere in between here. This is right here. Let me use a screwdriver here. Right here you got a small standoff right here and a longer standoff on top. So if I was to take that apart, the flight controller would sit right around here, on top here. There'd be a little bit of plastic standoff on the bottom, this plastic standoff on top, and the flight controller would sit between each. This plate would go on top. And then from there, what you got left to do is to drill the holes to mount your motors. And this is always helpful to know which motors you're going to put on there, know the exact dimensions. And a lot of motors, what they're going to have is they're going to have a protruding main shaft on them. So you will need to drill a hole in the center for that protruding main shaft so that it can spin freely. Right. I do it very simply. I'll put 2 holes that go right through, right? And if you look on the bottom, I just re-drill the hole a little bit bigger so that my screw will actually fit through these holes to go in and secure the motor from under here. And the motor is secured with only 2 screws, which is not ideal. Some people will not like that. Let me show you what else you can do. Most motors will come with mounts that will look somewhat like this, and you could use these instead and put your mounts on there, right, and then put your motors on there and then go from there. That way you would be able to use 4 screws to secure your motor on there. I don't think it's necessary for a model this light, and these are aluminum arms, and it works just fine with 2 screws for this particular rather small and light frame. Okay, so this is about as much information I guess you'd need to know about the frame. Like I said, you can buy one and then put electronics on it, or you can make your own. And as far as making your own frame, there's an array of different material you can use, going from plastic, polycarbonate, carbon fiber, aluminum, and so on for the arms and the center plates. But again, the idea is to really be very, very careful to drill your holes at the right place for your arms, so that they line up in a perfect X, and also so that they line up on the mounting holes on your flight controller, whichever flight controller you're using, so that this is going to fit nicely on there. If you're going to use metal screws, I would recommend getting them to stick out just a little bit out of the frame where you would mount basically the flight controller on there, and add some little mini standoffs. Let me show you here. Put some here. Put some tiny little standoffs like this, right, that I would put over the metal screw, and then mount the flight controller on the plastic. Why? Well, it's simple. If you get into a nasty crash with this, and the center plate breaks, and the metal screws that are there end up bending backward, you're going to snap that board. And on a couple places on this board, you got circuitry really close to the mounting holes, so you're going to ruin the board. Whereas if you use little standoffs on there to mount the board on plastic, if you're going to have a serious crash with it, very good chances are these standoffs are not going to be strong enough to break the control board. The standoffs will break, and your flight controller will remain in good condition. So that's it for the frame. This is the first video. In the next video, I will show you how to basically install motors, how to connect the motors to ESCs, electronic speed controllers, and how to build a power harness, which will basically be powering your ESCs, your motors, and also powering your KK2 board and your receiver. Stay tuned.